Alright, we are here on Notes 10.3, Special Right Triangles. And so I'm going to start by showing you how our formulas are derived. And so if you take a square and divide it completely in half diagonally, that gives you a right triangle. And so we could set up our Pythagorean theorem using this to find our diameter. And so these two sides we know are the same. So this is x, and this is my diameter that I'm finding. And so we know Pythagorean theorem is our a squared plus b squared equals c squared. And so I plug in my x squared plus x squared equals my diameter squared. Combine my like terms to get 2x squared equals my diameter squared. And then I take the square root of everything. And so because these are not, we have an x squared and a 2 squared, I can take the square root of them separately. Square root of x squared is just x. And then I'm left with square root 2, and so my diameter equals x root 2. And when we're dividing that line in the middle, we divide those 90-degree angles exactly in half. So this is called a 45, 45, 90 triangle. Anytime you have a right triangle with 45-degree angles, you can follow this pattern. So the nice thing about this is we don't have to go through and do this formula for every problem. This is the shortcut. We just have to remember the two short sides are the same. The third side is equal to x multiplied by square root of 2, or x root 2. So the way this looks like, so we can get into problems, is simple. If BC is 5, what do you think AB is? It's just going to be 5. They're the same. They're both x. And if these are both 5, what would the AC be? It would just be 5 root 2. Nice and simple. Keep the 5, add the root 2. That's all we can do. There's no way to simplify that further. So then on the next page, we have the long side this time is the one that's labeled. So here I am going to do just a little bit of math. I'm going to start by labeling my two short sides with x. This side is x root 2. And then I just put an equal sign in there. And so anytime you're a little mixed up on these, just label the sides and put equals between whatever your formula is and your number. And so I need to solve for x by itself, because that's what this side will be, so I just divide by root 2. If you remember from yesterday's lesson, when we divide by a square root, we cannot leave it in that format. I have to simplify. So that's one of those non-allowed formats in math. And so the way I simplify that is multiply by my factor of 1, which is root 2 over root 2. And that gives me 4 root 2 on the top over whole number 2. And then I can reduce. So 4 divided by 2 just becomes 2. So that is my answer. That's x equals 2 root 2, which means AB equals 2 root 2 and BC equals 2 root 2. Alright, problem 3. You might be thinking this is more complicated because there's a square root in there. In reality, it's actually much easier because this is our x root 2. This is x and x, so we're trying to solve for. And here, when we divide by root 2, it divides evenly. So 30 divided by root 2 just equals 15. So I have 3 root 15. Isn't it nice when things divide out evenly like that? Alright, and then next, we have 2 root 3 on my x side. And so BC is really easy because BC is just the 2 root 3. It's the same. AC now, if this is x root 2, and I already know what x is, all I have to do is plug that in. So what I do is in the place of x, I put 2 root 3 times root 2. And then I multiply my like terms, multiply my radicals to get 2 root 6. And that's my answer.